Hi there guys, so in this video we're going to be looking at the inverse form of a parabola. And so we are given the function fx, which is equal to a half x squared. And so now to find the inverse of a parabola, we need to follow these steps. First we're going to swap x and y. Then we're going to make y the subject of that formula. Then we're going to draw both the inverse graph and the original graph. And the inverse graph will be a reflection of the original graph about the y equal to x line. So I'll talk about this when we draw the graph. Let's first look at the algebraic implications of swapping x and y. So when we work out the inverse, and the notation we use for inverse is the f with the -1. Kind of look like an exponent, but it's not exactly an exponent. But that's the notation we use, and we are going to swap x and y now. So the fx is our y, that should now become x, and this x should now become y. Okay, so now we need to make y the subject of the formula. First I want to get rid of the half. Yes, you can divide by a half, but instead of doing that, I'm going to multiply by 2, which would also cancel out the half. So if I multiply this by 2, I'm then just left with y squared. And so I multiply the x as well by 2. Then to make y fully the subject of the formula, we need to take the square root on both sides. If you take the square root on the right hand side, you'll just be left with a y. And once you take the square root on the left hand side, you get plus or minus the square root of the 2x. Square root of 2x. Okay, and this is the equation for the inverse graph. So let's just complete it by writing the inverse of f is equal to plus or minus square root 2x. There we go. Now to draw both functions, I'm going to be using the table method, because the table method is such a reliable method and it works for every graph. So we're going to substitute different x values. You could see I already put in the x values, and I'm just going to work out what the y values is for each x value. So if we substitute x with -2, this is -2 squared, that gives us 4, and 4 multiplied by a half is just 2. So I'll fill this in as 2. And I do the same for every other x value. -1 squared times a half is 1 times a half, which is it just a half. And then 0 squared is 0. 0 times a half is still 0. Again, 1 squared is 1 squared is 1, multiplied by a half, it's also just a half. And then 2 squared is 4. 4 times a half is 2. Okay, let's first plot these points on our Cartesian plane, and then we draw the graph. So -2 and 2, that's somewhere here. -1 and a half, that should be about there. 0 and 0 is the origin. 1 and a half should be in line, and then 2 and 2 should be over here. Okay, it's a parabola, so we will have these repeating values. Just draw a nice curve going through those values. Okay, and don't forget the arrows to show that the graph continues even beyond these coordinates. Right, now let's draw the inverse of this. So first, I'm going to change the color. We'll use green. And we are going to, well, instead of me finding new coordinates, I'm going to take the same coordinates and I'm just going to flip them, because we swapped x and y, so the coordinates should also swap. And so that's what I'm going to do by swapping the x coordinates. So the x coordinates will be these. It's the 2, half, and 0. And then the y coordinate would be these. The -2, -1, 0, 1, and 2. Okay, so let me plot them on my Cartesian plane. 2 and -2. So where x is 2 and where y is -2. That should be over here. Where x is a half, y is -1. It's a bit weird plotting like this because it's the inverse now. And then when x is a half, y is 1 again. And then where x is 2, y is +2. So it's at the same point here. Okay, so we'll just draw another parabola, but this one is sideways, so it's the inverse of a parabola. This is not the normal parabola. Okay, our graph should go through all the points that we've plotted. Okay, so you can compare now the two graphs to each other. The first one was a smiling face facing upwards, and the other one is like kind of like a slanted face, I guess. And you can see that there's this line that we can draw that shows the reflection between the two graphs. And this line is the line y equal to x. That's the equation of this line. So it's not a random name, it's the equation for the line. Okay. Now, let's write down the domain for these functions. So the f function, your parabola, has a domain of all the x values, that's an element of the real numbers, and then it has a range of all the y values greater than or equal to 0. Okay. And that does make sense because the parabola is drawn above the x-axis, which is greater than 0. But the domain for the inverse graph, we're only making use of the positive x values. So it's only the x values that is greater than or equal to 0. And the range, as you can see, is all the y values, negative and positive. That's the plus and minus. So therefore the range is an element of the real number. Now, I've been calling them both functions, but that is actually a mistake by me, because only one of them is classified as a function. The other is only classified as a relation. The parabola is a function, but the inverse of a parabola is just called a relation. So we can't call it a function because there are two outputs. Whenever you have a one-to-many mapping, which this function has, then it's not classified as a function. So one input can't produce more than one output. And that's why this functions doesn't behave like that, so therefore this is not a function. We can also test this with a vertical line. If I draw a vertical line through this graph, it cuts the graph at more than one point. And so we call this a one-to-many mapping, which makes this not a function. Cool.